Hey there, class. Welcome to your homework assignment for section 4.8. Today we are going to be working through this packet together, taking notes on everything I write down on mine. So by the end of this video, our papers are twins. Today we are going to be moving on to section 4.8, which is all about solving equations with fractions. So we're putting together two of the skills we've already learned and now using it to work on more complex equations. Now remember, our goal in solving equations is to always isolate the variable. So if you're ever unsure of what to do in an equation, ask yourself, what's going to help me get the variable alone? So let's jump right into some examples so you can see how we're going to apply what we've learned about fractions so far to our equations. Now, remember, we must use inverse operations if we're trying to get across the equal sign. We're trying to move to the other side of the equation. Now, for this equation, x minus 3/4 equals 1 over 20. So right now, the operation that's happening is minus 3/4. So to get x alone, we've got to move the 3/4 over to this side. Right now we're subtracting it, so our inverse operation is going to be to add it. However, we are now adding 1 over 20 plus 3 over 4. We don't have common denominators. So to add these, we're going to have to multiply by 5 so that this is 120 and this is now, 15 over 20. Now we can add it together and we get 16 over 20. So what's left in my equation is x equals, and then it's 1 over 20 plus 3 over 4. That's what we just did here. We made it common denominators, added it together, and we get 16 over 20, but that's not simplified. So we're going to divide each of these by 4, and we get 4 over 5. So x equals 4 over 5. All right, now this next one, I want you to pause your video so that you can try this first, then check your work with me. That's how you're really going to learn the best and what's going to help you be prepared for our next class. So at this point, you should have done this one already and then pressed play. So now let's go over it together and see if your steps match mine. Y minus 2 over 3 equals 5 over 12. Well, we're subtracting 2 over 3 and we want y alone, so we're going to add 2 over 3 so that it cancels out over here and moves to the other side. However, 5 over 12 plus 2 over 3, we don't have common denominators. So we're going to make this an LCD of 12 by multiplying the numerator and denominator of the second fraction by 4. 3 times 4 is 12, 2 times 4 is 8. Now we have equivalent fractions with common denominators. So 5 plus 8 is 13 over 12. So y equals 13 over 12, which is 1 and 1/12. All right, let's look at the next example. Now we're multiplying. Here was just an example of what happens when we add or subtract. But now we have 1/3 times x equals 7. So if we are trying to separate the 1/3 and the x, we have to do the opposite of what's happening here, which means we would need to divide. However, if I have 7 divided by 1 over 3, that turns into 7 times 3 over 1 with keep, change, flip. So to cut out some of those steps, when we see 1/3 x and we're trying to separate them, we know that we can cancel them out by multiplying by the reciprocal. So here I'm going to multiply by 3 because that's the reciprocal of 1/3. So here we multiply by 3. So we get x equals 21. Okay, so now I want you to try this one. Press pause, then press play when you're ready to go over it. All right, so you just pressed play. You should have finished this one already. We have 1/5 times y equals 2. So we want to divide by 1/5, but we know that that's really the same, dividing by 1/5, as multiplying by 5, right? Dividing by 1/5 is the same as multiplying by 5 wholes. So to cancel this out and get y alone, we're going to do the opposite operation, the inverse, and we're going to multiply by the reciprocal, 5/1. 5 times 1/5 cancels out and just leaves y. 2 times 5 is 10. So our answer would be y equals 10. All right. Go ahead and flip to the next page. Now, these are a little bit different, but the same strategy. If we have multiplication and we want to divide by a fraction, that means we're going to multiply by the reciprocal. All right, so remember the reciprocal is when we flip it upside down, and instead of dividing, we're going to be multiplying. Really, this is just summarizing what we do in keep, change, flip. So here, if we have 3/5 times a equals 9, to get a alone, we're going to multiply by 5/3. You multiply by the reciprocal. So that cancels out, and then we do the same thing to the other side. Multiply 9 by 5/3. So that leaves a equals 45/3. And then when you simplify that or divide it, you get a equals 15. So now try this one on your own. 5/7 b equals 25. Now, if you've already done it and you pressed play and are ready to check it, let's do that together. So if we have 5/7 times b, then to divide that, we're going to multiply by the reciprocal. So we're going to multiply both sides by 7/5. And we get b equals 175/5. Now when we do our division, that gives us b equals 35. All right, let's move on to the bottom two. Now we have 3/4 x equals -1/8. Now we have 3/4 times x, so we need to divide to get rid of the 3/4 and get x alone. Now dividing is multiplying by the reciprocal, so we're going to multiply by 4/3. That cancels out, so x equals negative, well, before I multiply, I want to remember I could simplify my diagonals. 1 and 3 can't be simplified, but 8 and 4, 8 divided by 4 is 2, 4 divided by 4 is 1. So now this is really -1/2 times 1/3. So x equals -1/6. Okay, last one. Press pause and try it, then press play to check your work. Here we have negative 7/10 x equals 2/5. So we want to divide to get rid, or to separate the 7/10 from the x. And to do that, we multiply by the reciprocal. So we're going to multiply both sides by 10 over 7. Oops, negative 10 over 7, because it was a negative 7/10. So that leaves us with positive x equals 2/5 times negative 10 over 7. Now I simplify. 5 divided by 5 is 1. 10 divided by 5 is 2. And then I multiply. 2 times negative 2 is negative 4. 1 times 7 is 7. So we get x equals negative 4 over 7. Okay, hopefully we're feeling okay with this so far. If anything feels fuzzy, the beauty of video is you can rewind and listen again. If you're done copying everything on this page, let's flip to the next side. So here we have, this is 8y equals negative 2 over 11. I think that's an 8. So here's what, let me rewrite this so we can see all the numbers. 8y equals negative 2 over 11. Now, with this situation, this is really 8 times y equals negative 2/11. So, to separate the 8 and the y, we have to divide by 8. So, we're going to divide by 8. Now, y equals negative 2 over 11 times, because we're going to keep, change, flip. So divide turns to multiply, and 8 turns to 1 over 8. That becomes negative 2. Oops. Actually, we're about to skip a step and make our jobs harder. Before I multiply, I'm going to simplify. 1 and 11 are prime, but 2 and 8 can both be divided by 2. So we get negative 1 times 1 is negative 1, and 11 times 4 is 44. So our answer is negative 1 over 44. Now the last one, using our last example, go ahead and try this one on your own. You want to get x alone by canceling out the 5. So you should have just tried this one on your own. Now you've pressed play. Let's check it together. So this is 5 times x equals negative 3/4. So we have to divide by 5. Now that leaves us with x equals negative 3/4 divided by 5 means times 1/5. Now, before I multiply, I check to see if I can simplify, and I can't. So x equals negative 3 over 20. And that would be our answer. So let's move on to a different strategy. If an equation contains fractions, it is helpful to first multiply both sides of the equation by the LCD of the fractions. This eliminates the fractions. We like this. If we can get rid of the fractions, then we know how to solve these. So let's look at this example here. So they wanted to do x over 6 plus 1 equals 4 over 3. Now, before they did anything else, they multiplied by the LCD. Now, the denominators were 6 and 3, so LCD is 6. Notice how they then multiplied both sides of the equation by 6. So that cancels out here and leaves just x. And then over here, it cancels out and becomes 2 times 4. Notice, if we did it the original way with fractions like we were just practicing, we'd still get the same answer. Now, helpful hint, don't forget to multiply both sides of the equation by the LCD. All right, we always have to be sharing the love. We have to keep it balanced. We have to do the same thing to both sides. Okay, so let's flip the page and try that. Now for this first one, we have y over 8 plus 3 over 4 equals 2. So we said the first thing we were going to do is multiply by the LCD. Now the LCD of 8 and 4 is 8. So we're going to multiply this side by 8 and this side by 8. So this 8 and this 8 cancel out. So that's just y plus. And then this one is 8 times 3 over 4. They can be simplified, so we get 6 over 1, which is just 6, and that's equal to 16. So let's backtrack a little bit. So here we multiplied everything by 8. So when we did y over 8 times 8, it canceled out. When we did 3/4 times 8, this became 8 over 1, and then we simplified the fractions. So that's how we got 6 over 1. So this is really y plus 6 equals 16. So then we subtract 6, and y equals 10. Now let's try another one. Here we have 6 and 3, so the LCD here would be 6. I'm going to multiply both sides by 6 over 1. That cancels out this 6 and then multiplies this by 6. So it's really x over 6 times 6 plus 1 times 6 equals 4/3 times 6. We multiply everything by that LCD. So this cancels out. 6 times 1 is 6. Now 6 and 3, they can be canceled out. So we get 8 over 1. So x plus 6 equals 8. Subtract 6, and x equals 2. All right, so that's our second strategy that we could use. We could do it the fraction way or the LCD way. Now we're going to wrap up by solving a couple final equations. As a reminder, this box here has all of your steps for these equations. This is your how-to guide. So if you get stuck on a homework assignment, you look back at this yellow box and use it as a checklist to check off each step that you do. Now, for this first one, we have, oops, let me focus this, there we go, z minus 5, or z over 5 minus z over 3. Now, we can't do anything until our denominators match. So, the first thing I'm going to do is I could make these common denominators, or I could multiply the equation by the LCD. So if 5 and 3 are our denominators, our LCD is 15. So we're going to multiply this side by 15 and this side by 15. So that gives us 3z minus 5z equals 6 times 15, and that should be 90. Now, the reason I got 3z and 5z, let's look down here. So we did z over 5 times 15. Now remember, this is 15 over 1, and before we would multiply, we would simplify. So 15 and 5 can both be divided by 5. 15 divided by 5 is 3, 5 divided by 5 is 1. So this becomes 3 times z, 3z, 1 times 1 is 1, or 3z. Same with z over 3. So if we did 15 times z over 3, this cancels out and becomes 1. This becomes 5. So 5 times z is 5z. 1 times 1 is 1. So that's how we got 3z and 5z. Now 3z minus 5z is negative 2z equals 90. Divide by negative 2, and z is negative 45. Okay, so let's use what we just did now to make sure it makes sense. Here we have x over 5 minus x equals 1 over 5. So we want to multiply by the LCD. Well, they already have a common denominator, so we're just going to multiply both sides by 5. So that's going to cancel out the denominators. So x minus 5x equals 5. Nope, 1. Now, x minus 5x is negative 4x equals 1. Now, negative 4 times x. To undo that, we divide by negative 4. So x equals negative 1 over 4. All right, we're getting there. Go ahead and flip to the last page. We're just going to do a quick review of adding and subtracting fractions, and then we're done. So 9 over 10 minus y over 3. We need to find the LCD of these two fractions. So I'm going to do 10, that's 5 times 2, and 3, that's 3 times 3. Now, that's 5 times 2 and 3 times 3. So I have 1, 2, 1, 5, and then the most 3's I have are 2 3's. So 2 times 5 is 10, 10 times 3 is 30, times 3 is 90. But that doesn't seem right, because I know they have an LCD of 30. They can both go into 30. So I'm just going to multiply this one by 10 and this one by 3. And I get 27 over 30 minus 10y over 30. Now I realize where we made our mistake. And this is a good example of some of the things I saw on the quiz. Look at this mistake. This is so silly. 3 is really just 3 times 1, not 3 times 3. So then our LCD is just 2 times 5 times 3, and that equals 30. Now, we have common denominators, so we're going to subtract 27 minus 10y over 30, but we can't go any further because they're not like terms. Unlike terms, so we can't combine them. So we just leave it like that. All right, let's look at the next one. 3 and 5, the LCD is 15. So I'm going to multiply this fraction by 5 and this fraction by 3. So 5x over 15 plus 6 over 15. Now the denominator stays the same, and we add the numerators, but they are not like terms, so we leave it like that. And the last one we're going to wrap up with, which of the following are equations and which are expressions? So our equations, think about, what did we say makes an equation different than an expression? An equal sign. So the equations here would be A, 1/2 plus 3x equals 5, and D, x over 5 equals 1 over 10. Our expressions are the ones that don't have an equal sign. So that would be B, 2 over 3x minus x over 5, and C, x over 12 plus 5x over 24. So that would be our final answer for equations versus expressions. Now that's it for tonight. So please review these notes. All notes in this packet before next class. All right, we're going to be moving on with these skills, maybe even playing a game if you all come prepared. So complete these notes, review them, and then I will see you at our next class meeting. Have a great afternoon, guys. Hasta la vista.